Consider the following statement. This statement is false. However, if this statement were to be false, that would mean that the statement is in fact true. However, if the statement is true, that would mean that the statement is false. Ultimately, this is the backbone of Gödel's incompleteness theorems, the limitations of mathematical proofs. A proof is a logical argument about why something must be true or must be false, and these are built from the ground up by axioms, undeniable statements from which even the most complex of proofs are built. So if something must be true, it should be able to be proved using an axiomatic approach. In the early 20th century, mathematicians had the goal to prove that mathematics had no contradictions, so mathematics was perfect, i.e., every statement or its negation could be proved. However, Kurt Gödel questioned whether this was true. Coming back to the first statement, this statement is false. This is an example of a self-referential statement, i.e., referring to itself. And although creating a logical paradox is quite easy to do with words, it's a lot harder to create with numbers. In fact, to do so, Gödel created something which is now referred to as Gödel coding, where he assigned every symbol a number. And in doing so, Kurt Gödel created the world's first self-referential mathematical statement. This statement cannot be proved. Unlike the first ambiguous statement, this statement is a mathematical statement, and so it must either be true or false. Consider when this statement cannot be proved is false. That would mean that the statement does in fact have a proof, and so the statement must be true. This contradiction forces us to think that this statement cannot be proved is true. This shocking discovery crushed the hopes of those who believed that every mathematical statement would one day either be proved or disproved. In fact, Gödel went as far as saying that if a mathematical system could completely be proved to be true, that would system itself has contradictions within it. And only in an incomplete mathematical system can every statement be proved true. Hence, Gödel showed us that mathematics will never be complete.